Hello everybody, in this video we're going to go over pages 4 through 6 in your packet. You should have your packet out and be ready to go, and I'm going to go and get going here. I'm also talking a little bit quieter because my family is just waking up. Okay, we're going to do what is a limit, and we have this function f of x equals x squared minus 3x minus 4 divided by x plus 1. They want to know what's the domain of f of x. Yeah, we could do that. Let's do it. We can see that this is factorable over the top. And if you can't see that, no, I'm not even gonna say it. You can see that. You can see that. It looks like these x plus 1s are going to cancel. They're going away. Bye-bye. And now we're left with this x minus 4. But with the condition that x cannot be equal to negative 1. Because if we plug in negative 1, we get 0 over 0, which is a little bit of a problem for some math. So what we have instead is all real numbers for the domain of f, except for x equals negative 1. And we'll see later on the next page what this is going to look like, but essentially it's going to be a line. A slope of 1, because the slope of this equation is 1. Y-intercept of negative 4. Just going to be a nice line from algebra 1, but a hole at negative 1. So again, a domain, all reals, except x equals negative 1. And there is a fancier way to write that. If you want to do negative infinity, negative 1, with a negative 1 to infinity, that'd be fine as well. For number 2, what does the graph look like? Oh, hey, look at that. We're talking about the graph of f is going to look like a line with a hole. And the hole is going to be at x equals negative 1. Now, where would the y value be? Good question, Mr. Lakin. Thank you, Mr. Lakin. The y value is going to be, if I plug in negative 1 here into this equation, I have negative 1 minus 4, which equals negative 5. My hole is going to be at negative 1, negative 5. The next part says 3, and that there's a table here of values. And what we're going to look at is trying to see what the limit is on the left using a table. And this is a helpful skill, especially if you're not able to kind of see the graph, or if you need to kind of, if you have a limit that you have to do by hand and you want to kind of, you can't visualize what the graph looks like, but you can plug in values that are closer and closer and closer to that x value you want. Now you can kind of zoom in on what that y value is. And that's what we're going to do here with this organized table. What you're going to need to do, though, is plug this equation into your calculator. It was x squared minus 2x minus 4 over x plus 1. Don't use x minus 4. No bueno. You want to use x squared minus 2x minus 4 over x plus 1. I'm going to open up my calculator app. I have it in here already. If you were not able to get the fraction bar in your calculator, which some of you may not know how to do, which is okay, I want you to go and do alpha y equals, and you can pause here, select number 1, and you'll have the box and you can type that in. So please pause to catch up. And then when you're ready, let's resume and let's go ahead and keep going with the table on the calculator. Okay, now for the table part, if I go to table, oh, there's nothing there except a 10-6. And many of us, when we go to our table, are going to have an automatic list of numbers. We're not doing anything with those numbers. Instead, since I already have a list of what I want for the table, I don't want the table to automatically populate. So what I'm going to do is go to a table setting. The way you're going to get there is second window. And table start anywhere you want, doesn't matter. Table change, it doesn't matter for that second row. But this last one, independent, set that to ask. And what that's going to do is going to say, what is the x value that you want to use? And I'll give you the y value out. That's what the calculator is saying. Let's do a second graph to go to the table. And now we can see here that it's blank, and we can clear it out. Hold on. And we can clear out the values. And now I'm going to go and type in what I need here from the previous page. And I'm just going to alternate once to make sure I have the right values. Okay, so we're going to need negative 2. Oh, is negative 6. And you might have to push enter on yours. Mine automatically does this since I'm using the app's calculator. And then I also need negative 1.25. And I need negative 1.1. Nope, negative 1.1. And I also need negative 1.001. And this is a lot easier to have to use instead of doing the old-fashioned way of plugging each one in individually. So you finish up this, pause the video, and resume when you're ready, and we'll get the answers. Now, I repeated this for both already, and what I'm going to do next is answer the questions. The limit as opposed to negative 1 on the left is going to be, it looks like these values on the left side of negative 1 are getting closer and closer and closer to negative 5. If we look at the same thing for the bottom one, for number 5, if we're on the right side of negative 1, and we get closer and closer and closer to the right side, we end up also getting negative 5. Yeah, 2 minutes. Graph f of x and draw the left and right hand limits. This is going to look like x minus 1, but there's going to be a hole at negative 1, negative 5, we said. The left hand limit is in red. The right hand limit is in blue. And when the left and right hand limits are equal, they both equal negative 5. You can write a few sentences on your own to describe what the limit is. And then finally, the limit as x approaches 2 of f of x does not exist because on 2 on the left is going to be equal to 2 from the picture, but the limit as x approaches 2 on the right of f of x, that's my son, is equal to 5. And this limit, don't worry about this one. And the limit as x approaches 0 of h of x on the left and the right does not exist because the y value doesn't approach a number. We're not watching, okay? We gotta go have breakfast, come on. I went to the next page, I'm just filling out this last part. Limit as x approaches a on the left is not equal to limit as x approaches a on the right. And we only have 1 more minute on this video. We have a vertical asymptote. And then the very least popular one, and oscillating discontinuity is 1. This x approaches a of f of x does not exist because f of a is not defined. I know I'm going faster because my son is awake and requesting Peter Rabbit. And then we have an oscillating discontinuity. This is a least common one, as I already said. And I would not spend your time doing that. Oscillating discontinuity, just because the y value is fluctuating so quickly in between, as was showing on this last page, that there is no y value that's established there. And you can see that the y value is undefined when x is equal to 0. So that's an oscillating discontinuity or an essential or a non-essential discontinuity. But this is not tested on AP, and we won't go over it in the class beyond this point. The first two are not an X. The first two are necessary to know, and they both go with the f of x and h of x above. And that's it for the video. Thanks for watching.